Today, a design might go either way. The University of Houston presents this series about the machines that make our civilization run and the people whose ingenuity created them. Good engineering means guessing how change will occur, but that's hard to do. It's a lot like bull riding at the rodeo. A rider never knows just how the bull is going to zig or zag. Same with engineering. Too often we have to ride such cusps. Example, it was clear, even before the Wright Brothers, that airplane engines would have to be lighter weight forms of the new internal combustion engines. Samuel Langley powered his new airplane with an engine based on an early car motor. Once launched, it sank like a stone into the Potomac River. 9 days later, the Wrights succeeded with their own light engine design. The Wrights saw which way their bull was zigging. Langley did not. But that set the stage for a different kind of bull ride, one that lasted decades. Here's how it went. A mixture of fuel and air burns explosively to drive engine pistons, so we have to cool their cylinders. We can do that in either of two ways in an airplane. We can fit them with a jacket of cooling liquid, or we can let air blow past them and cool them like a huge fan. That means either of two arrangements. We can line cylinders in a row when they're liquid-cooled. That lets us make the airplane thin and more streamlined. But then the airplane also has to carry extra machinery. More weight, more cost, more maintenance. So what about air cooling? Combat airplanes needed strong engines with many pistons. That meant arranging them in a circle facing the wind. So air cooling meant more wind resistance, but it also took far less complication and cost. Many World War I airplanes went further. They let the engine spin around a fixed crankshaft. The spinning engine then cooled itself nicely, but the engine also acted like a gyroscope and made flying somewhat tricky. The Germans favored liquid cooling in World War I, but not entirely. The Allies leaned more toward rotary air-cooled engines. After the war, the new commercial aircraft favored air-cooled engines, but there was also a new competition for speed, and racing planes were again undecided. Then World War II. Now armies on both sides favored liquid cooling, but most navies used air cooling. And the very first engines. The Wright Brothers used liquid cooling. Glenn Curtiss and Santos Dumont used air cooling. Indecision went from the very beginning until jet engines burst on the scene and cylinders almost vanished. But not quite. Today, most very light airplanes use air to cool only a few cylinders. So, engineers rode a cusp throughout the first half of the 20th century. Back and forth. Two technologies, neither of which could win the day. Which way was the bull lurching? Then the ride ended as swiftly as being dumped from a bull. It did so as most large aircraft switched from piston engines to jet propulsion in hardly the blink of an eye. I'm John Lienhardt at the University of Houston, where we're interested in the way inventive minds work.